Everyone, hi, this is Suresh Patil. I am here to present you my major project, that is comparative study of decision tree algorithms. We are a team of 4 members, that is Suresh Patil, Mahesh B, Swamy B, Tejendra Varma. We have worked on this project under the esteemed guidance of Mrs. Beena Bithra. So, our project is basically the comparative study of 3 decision tree algorithms, that is ID3, C4.5 and CART. ID3 and C4.5 works on discrete databases, whereas CART works on continuous databases. So let me introduce by saying what is a classification. Fine. A classification is a form of data analysis that extracts models. Say when you go to a bank, the bank manager classifies your bank loan applications are either as safe or risky, and then he allocates you loan based on the previous data analysis that he gets from the previous customers. So examples of other classification tasks can be predicting tumor cells as benign or malignant, classifying credit card transactions, classifying secondary structures of protein, classifying news stories, and etc. So how does this classification basically work? A data classification is basically a two-step process, say learning step and classification step. In learning step, the classification algorithm, that is ID3 or C4.5, builds the classifier by analyzing or learning from a training step. Whereas in classification step, the model built from the learning step is used to predict the class labels. As I explained you, safe or risky is called the class labels. So in learning step, see the learning step here is a database that we call it as training data. The training data can have the attributes, and this is a class attribute that is known underscore decision, where we apply the classification algorithm. Our main focus will be on this classification algorithms on which we are working on, that is ID3, C4.5 and CART. And this classification algorithm, when applied on the training data, gives us the classification rules. Say if age is youth, then the loan underscore decision can be risky. So the predicted value is risky, and similarly the below two. In classification step, the test data is applied on the classification rules along with the new data to classify the predictable values, that is risky, that is the loan cannot be allocated. So decision tree. So based on the classification rules that we have got in the previous steps, we categorize a decision tree. A decision tree is a flowchart like structure where each internal node denotes a test on the attribute. Each branch represents the outcome of the test, and each leaf node holds a class label. This is the training database on which we are working on. Say this is a class attribute that is by some underscore computer, no yes youth. So this is a decision tree form. Say age is middle age, then it is directly yes. As you can see in the previous database, where all age of middle age all have the class underscore by underscore computer is as yes. So the decision tree is induced from the above example. Say if age is youth and student, and if he is a student, then no. If he is not a student, then no. That is, he doesn't buy the computer. If he is a student, then yes, he buys a computer. If age is senior and the credit rating is fair, then he doesn't buy the computer. If age is senior and the credit rating is excellent, then he certainly buys the computer. So the information gain. So these are the 3 basic algorithms that we are working on. It is ID3, C4.5 and CART. Entropy, split based on info. So we have also worked on the tree pruning techniques here. That is, a tree pruning optimizes the tree and gives us the optimal results. The tree pruning can be of 2 steps, of 2 types actually. That is pre-pruning and post-pruning. Here the tree is pruned and halted its construction. Post-pruning removes the subtrees from a fully grown tree. So let me explain you with our execution. So this is the application that we have developed. Here you can see this is the database, a database that is a basketball, where we try to predict the result of the basketball match, and we can also load some other databases like computer science class, car evaluation database, or these are all the databases that we have been loading. So let me load you the play tennis database, where based on the attributes outlook, temperature, humidity and windy, the class attribute play tennis is found out. So we can apply 3 algorithms on this, that is gain ratio and Gini. So let me apply gain first, and let me run this algorithm. So this is the decision tree that we have formed. That is when outlook is uh, when outlook is sunny and it is humid and the humidity is high, then the tennis match cannot be played. If it is normal, then the tennis match. If the outlook is if the outlook is overcast, then the tennis match is played. If outlook is rainy and it is windy, then the tennis match is not played. And if it is not, then let us see by loading another database, that is basketball. And let me run this. Okay, so I'll explain you more clearly. When it is 5 p.m. and John plays defense in center, then the match is lost. If he plays in forward, then the match is won. Similarly, the other. When it is 9 p.m., whatever happens, the match will be lost. So we can see the node accuracies here. If it is red, then the 100%, all of which are defined. Let me try with another algorithm on the same database. Let me try Guinea and let me run it. You can see there's a difference here. All the other databases are not fully classified here. Let me run the gain ratio for this. Let me run Guinea. And let me load the reduce error. Sorry. So let me run gain and then let me run the reduce error function. Right. I have to define the testing database. Okay. So let me run now. So based on the testing database we have taken, that is the we have been predicting the loss or the won of the match, of the basketball match. Similarly, okay. And let me take you to my PPT. So we have applied the tree pruning, that is pre-pruning and post-pruning. Thank you for watching the video.